Hey guys, Seth here with Arc and Chip Fabrication. Today we're going to be working a little more on this Craftsman Lathe. The idea is hopefully we're going to be making a lantern type tool post holder for this machine. Because of how it's set up, not having a lead screw, if you watched the last video, I don't know just how practical this is going to be for what I need it for. It'll definitely do a fair bit of work. Would just take longer setup times, be a little bit more difficult, being as it doesn't have a lead screw. We have to move and clamp the saddle wherever you want to move it, and then you're limited with about 3 inches, a little over 3 inches travel on the compound. So just because of that, I looked at getting a lantern type tool post holder, buying one, or even you can get a quick change tool post, pretty inexpensive now, but still be looking at probably around $100 setup, and I don't want to invest that much into this, at least not yet. So in the short term, I have a little setup here that lets me use the two tools that came with it. I'm going to open this up and show you what I got going on here. I don't have a live center for this. I cheated and used an old grade 5 bolt, cut a 60-degree angle on it, and I'm just using this as a dead center for making this tool post. Again, not ideal. I'll probably order one. It's about 20 bucks for a number 2 taper live center. But again, just doing what I can with what I got. So this is the setup. I'm going to zoom you in and get you a little better view of that. So what we have here, I took a carriage bolt, ground the head of it down a little bit more flat, put a big washer on there, and slipped that into the slot on the compound. And then I have just a piece of scrap aluminum blocking to get the tool to about the right height. Another scrap of block to clamp against, and I just put a nut on it with a cap. All scrap I just had laying around, so I just kind of threw it together until we can get an actual tool post type thing made in here. What I'm working on, this is, actually you probably recognize this. This is a foundation jack. Again, just a bunch of odds and ends crap I had laying around. But this is the plate that's threaded 1'8" and the screw, so I'm using the screw as an arbor, and this plate I'm going to turn it down to fit into this slot, and then we'll build a tool post off of that. So this is what we're starting with. I did take some measurements on what the slots are in there. Hopefully you can see these. So the inside of the slot, the widest part is 1'809". The narrow slot, the groove, is 1'370", and it's got a depth of about 380 thousandths. So none of these are critical. We're just using these for reference. Make sure we'll get this part size right that'll fit in there, and we'll go from there. So tag along, let me know what you think. Again, this is not critical. It's not going to be high precision. This is more or less a project to do with what I got, which isn't a whole lot. So get this chucked up. Again, I did put a center hole in the end. Didn't have it. It would have been nice if it did, but there wasn't one in there. And so I just made this dead center, again, out of a piece of bolt. So with these, the important thing with the dead centers, not running this super high RPM. I mean, I wouldn't trust this lathe high RPM as it is. It wasn't designed for high RPM. So we'll keep the RPMs low. Let's run this in until it touches. Not a whole lot of pressure on there. Lock it down, and we're going to start cutting. Let's get to it. Alright, so for our widest diameter, we're going to be looking for right around 1'800", a little under. Again, the slot is measures roughly inch 809 thousandths. It is a little rusty, it's a little dirty, so I'm not terribly concerned about getting this spot on. But for right now, we have roughly, switch this back over to inch. I don't want metric. There we go. And I know these, I'm not a big fan of digital calipers, but again, it's what I got, so that's what we're going to go with. Right now we're at 2 inches, 267 thousandths, so we have a fair ways to go shooting for inch 800 thousandths. So let's start knocking it out. I did play around with this a little bit, getting used to the feeds and that. I did that off camera. Put a new edge on this tool. So we're going to go ahead and start cutting. As always, safety glasses first. I did, everything's gone through and oiled up every time I fired this thing up. I go ahead and hit the bearing journals with oil, bushings on the pulley, and this motor's got a little bit of squeal to it. I did find out this is definitely not the original motor. A little cleanup on that data plate, and it says GE washing machine motor. So not too worried about this motor. I'll probably look at replacing it at some point. I may, again, depending on how much we're going to use this, I may go with looking at getting a DC motor where I can do a variable speed and have reverse on it. Not really sure yet, but we're just going to work with what we got and have some fun doing it. And yeah, so let's get cutting. Touch this off. Touch off and set this to 0, and we're going to come in 10, 20, take a 25 thousandths cut. And this thing is all hand feed, so it's slow go, but take a lighter cut next time through. I'm going to even tighten this up just a smidge. There we go. Alright, so next one, we're going to do 20 thousandths this next cut. Do about 5 thou less. I haven't checked this thing if these indications are anywhere near accurate. I have no idea, so we're just going to play around with it and see what we get. It does appear to be measuring exact, so when this feeds in, say it feeds in 10,000, it's going to be taking a 20 thousandths, reducing the part by 20 thousandths, so it's 10 off each side. That's what appears to be how this one's set up. So don't know that for sure. I know some of them go one way or the other, but yeah, see, that's making a much better cut. And this is just a little piece of tool steel in here, nothing fancy, no carbide. That'd be nice, but again, just doing what we can with what we got. Take another 20. Got a measurement now, see where we're at. Okay. We're at 2 inches 144 thousandths. So we still got a ways to go. What I'm going to do is I'm going to go ahead and make this next cut. We'll feed in 20 according to this dial, and let's see what the actual measurement ends up being. So that was 2 inches 144 thousandths. So we'll feed in 10, 20, plug it in, and let's see what we end up with. Obviously this isn't going to be 100% accurate too, being as we're using a dead center, not a live center in the tailstock, so we're not looking to fine tune, just get a general idea with this machine of its style. It's all the way through. Alright, so now we are 2 inches 100 thou. Yeah, so we took about a 20 thou cut, so that'd take 40 thousandths overall within a few, and so it is like we thought. Each one of these is depth of cut, so your total will be reduced by double that amount. Anytime you get a new machine, always want to check, make sure you figure that out exactly, or put an indicator on here to find out. I don't have an indicator. That's again what we'll be getting down the road. But yeah, so we got a ways to go. That's 2 inch 100 thousandths. So we got about 300 thousandths to go on this part yet. So let's knock it out. All right, so we finished getting this down to roughly the size we want it. This pocket measured inch 809 thousandths. This part is now inch 800 thousandths. So that gives us 9 thousandths clearance. Not quite enough for what I want. I don't want it to fight me, and especially if it's going to be a little bit rusted. So I'm going to take just another 10 thousandths off the total. So I'm going to move my tool in 5 thousandths. We're going to fire it up and take one final cut, and we'll see what kind of finish we get off this too with tool steel. So let's feed it in nice and slow. see where we're at. We should be right around inch 790 thou. We are inch 791 thou. So plenty good enough. I can live with that. What I'm going to do is just break this high side corner before we go any further. Plug this back in. Okay. Stringer off there. All right. So next, the depth of this pocket is 380 thousandths. So I'm going to go 350 thousandths. And we're going to go ahead and scribe a line on this part, 350 thousandths. How about that, 350 thousandths. And so we're going to just knock that shoulder off up to that scribed line on the right. And we'll need to take that down to inch 370 thousandths. Alright, had to take a break, let my camera battery charge up. It's cooled off now. But so we're where we left off. We scribed the line, what we need to cut into. In turn, how this tool assembly was on here. Again, it'll be nice when this tool post is done and make this job a lot easier. But turn this around. So I'm just going to start cutting in and making this shoulder. And so this side will be the bottom that'll slide into the slot on the table, and this will be the narrower section that'll come up through into the throat of that slot. So we're going to go ahead and get this fired up, start cutting. I'm going to shift these belts and get this spinning a little bit faster now that our diameter is getting down. Let her cut a little quicker, a little smoother. It is taking some nice cuts, so can't complain for its condition and age. Go ahead and add a little bit more oil into these. And our spindles. Alright, let's fire it up and get cutting. First thing I'm going to touch off actually I'm going to see about clamping this motor down. This thing's hopping all over the place. I can't even see it now. Hopefully not a little C-clamp that fits. Let's try that. Oh, that's much better. Alright, so I'm going to move in, just touch off. Alright, there we go. Set this to 0. And so this outside was right around 790 thousandths. And so we want this inner shoulder to be inch 370 thousandths. So we're going to start pickling this off. I'm going to go in, let's try a 20 thousandth step to cut. And again, we're just going to go right to that line that's scribed down there. towel. And that's it. All right, let's check the measurement. So we are inch, inch 354 thousandths. This part is still hot, so we'll go ahead and let that cool, and that should be plenty good enough for what we need it for. Real quick, I am going to spin these back around and just touch off, break these corners on it. So, I get to see my fancy tooling set up here. Really about as crude and basic as you can get. But, it works until we get this tool post done. I'm going to fire this back up and just break these corners quick. That's that. Alright, so off camera I just took this down, took another 10 thousandths off both measurements, so that should give us plenty enough clearance to fit into this slot. And there we go, that's much better. That'll give us what we need. All right, step one done. So what we're doing now, I got a piece of another piece of threaded rod, a partial threaded rod. This is actually a stud that I replaced on a 16 gauge sheet metal brake for the same sheet metal shop that this other part is for last week. I didn't get to drop it off. I'm actually going to be running over there Tuesday, so I got this. I got some other parts I made for them. A little side note, these are ladder brackets made out of 1/4 inch by 2 inch bar stock. He wanted a few to mount on the side of his box van, so he's going to send these off and have them powder coated. But yeah, maybe I'll do a video on building these and show you my little homemade 6-ton press brake. So anyways, keep going what we're planning on. Again, this is a piece of threaded rod. This is 1 inch, and it is threaded for 8 threads per inch. This is what this fit onto. This is a jack. This is actually originally a foundation jack screw. This is a little bit undersized. This is actually 960 thousandths on the outside. This measures a true 1 inch on the outside. So it's a little snug in here. So I'll probably knock those threads down a little bit with a file, tapered file, and get it to fit on there. At the end of the day, I want that to be nice and snug, and we're going to come through and notch this so that the tool can fit up in between. So what we're going to do right now is face this end, drill it, and tap it for a set screw. So when this is notched, we can run the set screw down and tighten it onto the tool post. So I apologize, I didn't realize my camera was dead when I faced off the end of this shaft and cut the chamfer on it, so I missed that. Not a whole lot to it, nothing special. Was cutting off some welds, so it's a little bit finicky, but it got her done. So next we're going to drill, put a center in this, and then we're going to drill this through probably about 1.5 inches, 2 inches deep, and we're going to cut some threads. I got to find a set screw that I want to use and figure out what size. Probably going to use at least a 5/16 or maybe even a 3/8 square head set screw. We'll see what we got in the parts bin. So let's get it fired up and drill the center out. Yes, I'm not going to be able to set the camera on the lathe till I get a better base and get some of these imbalances out of it. Alright, let's see what kind of center we can find. Alright, so for mounting the top of this, I found a square head set screw. This is 3/8, so we're going to go ahead and drill this and power tap it for this 3/8 set screw. Tighten this back up. Alright, let's fire it up and drill this out. Put some oil on here. Alright, that should be plenty deep enough. get this drill bit pulled out. Get a tap. That is 3/8 16. There's a 3/8 16 tap. Alright, so like before, we're not going to use the hand wheel to feed this in as we tap. I'm just going to slide this up into it. Got plenty of travel here with the compound where it is, because we can only go into the threads because the shank's same size as the OD of the threads. So let's roll this up. Switch this back to low speed so we have most control over it. Let's turn it on and let's feed it in there. So because of this size and the threads, I'm going to feed it in there just a little ways. Need to tighten that chuck down a little more. Back this off and back it out by hand to clean those threads out. Okay. Alright, and I'm sure some of you are going to mention the fact that this jaw is biting on the threads. For this application it's perfectly fine, because once we finish working on this part, we're going to cut a notch up about 2/3 of the way into this. This will get threaded into this lower ring, and that's going to get welded from the back side. So those threads get a little marred up. It really doesn't make a whole lot of difference. Once it's in this part, it'll be welded in place and it's not going to be coming apart again. So that will be fine. Well, in short, that's a wrap. We got our threads in the part here. That's ready for set screw. That feeds right in there good. So again, we'll be cutting a notch straight through here, and then these cutters are going to be able to slip right up in between them. So that's the idea anyways, and we'll see if we can make it a reality. Thanks for watching. Hope you like it. If you want to see some more, go ahead and give me a thumbs up and subscribe, and I'm going to try to keep little bits here and there coming. Thanks, and we'll see you on the next one.